So this is the big graph, capital G, that we're going to be dealing with. And so this is a connected graph, meaning that if I can connect any vertices to anyone else, given a chosen path. Now, this is a weighted graph in the fact that each one of the edges has a different weight to it. Okay? So that weight could be distance, preferentiality, any number of things depending on the context of the graph that you are dealing with. Okay? And so what we're going to try to find is a minimal spanning tree. Okay. Or how should I phrase that? Yes, a minimum spanning tree. Okay, so the first way that we can do this is through Kruskal's algorithm. All right. All right. So now for Kruskal's algorithm, the very first thing we have is our input. Okay, now the input has to be, well, that graph that we just had up is a connected weighted graph within vertices. Right, so as long as we start out with a connected weighted graph, we're going to try to find out the minimal spanning tree of this graph, but you have to have an input first. Okay. All right, so now if I'm given a graph, a weighted graph within vertices, that's the input of the problem. And then we would have the algorithm body. Okay. And so the first thing would be to initialize T Okay. So when we talk about initializing T to have all vertices, you can initialize this as an array. But if we look at this in the sense of what are we dealing with in this case? So first thing I'm going to do is I'm going to initialize T. And if we look at our graph T, okay, so by initializing T, we're going to capture all of the vertices, meaning all of the lettered ones. Okay? And so T would equal to set A, comma B, comma C, comma D, comma E, comma F, comma G. All right. That's the first step of the problem. And so we're going to initialize T to be set of all vertices. And then for the second step of the problem, we're going to let E be the set of all edges. Okay. So what would E be? Let's include them by their weight. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So what we basically want to do is we just want to set up two sets. One set that contains all of the vertices and one set that contains all of the edges. Okay. That's just to get things set up. All right. Now we get into, all right, so the first one and the second step of this algorithm is just set it up so that you have all the vertices and the edges in two different sets, okay? Now, this third step of the algorithm states okay. So we're going to run a while loop, and so this is going to be containing three different things. Okay. The first thing is going to be find an edge E within capital E of least weight. Okay. Okay, so first we have to find out edge of least weight. And then the second step would be delete E from E. Okay. And then the third step would say if addition of E to edge set of T and just scroll up a little bit. Does not produce a circuit okay, then add E to the edge set of T. Okay. And set M to be M plus 1. Okay. And then what are we going to do? And while. Okay. Now after we end this while loop, the output will be T, right? Where T is the minimum spanning tree for G. So that's just the definition of this.